In the previous lesson, we've created the compile script, and now it's time to start writing FunC code. But you know what is cool? We are now equipped to actually see if our FunC code works. So once we write some FunC code, we will simply run yarn compile and make sure that our code is able to run on TVM. The smart contract in this lesson will be very simple, but this will be just enough for us to get familiar with basics of FunC syntax and structure. So let's get our hands on code. In the previous lesson, we already created contracts folder and main FC file inside of it. So now we are going to get back to this file, and you can see that we already wrote a handler for internal message. So we already defined this function, and as you remember from other chapters, you know that the messages are like everything that is coming between contracts. This is internal messages. So what is the messages bringing to us? You can see that there is 3 parameters that are already defined. Message value. This parameter is telling us how many tone coins are received with this message. And then in message parameter, this is a complete message that we've received with all the information about who sent it, the flags, and we can see that it has type cell. What does it mean? So the message body is stored in cell on the TVM once it's arrived. So there is one whole cell dedicated to our message with all of its data. In message body, this is the 3rd parameter. We can see this slice. So this is an actual readable part of the message that we received. It has type of slice because it is a part of the cell. It indicates the address from which part of the cell we should start reading if we want to read this slice, this part of the cell. So as you can see, both message value and in-message body are derivable from the in-message cell. But for the usability, we receive them as parameters. So we don't have to read them out every time we handle this function. So important thing to talk about is function specifiers. So I'm sure you've noticed the impure word here. This is one of 3 possible specifiers that could be there, and it is impure. There could be also inline or inline ref, and there could be method ID. One, several, or none of them can be put in function, but currently they must be presented in the right order. It's not allowed, for example, to put impure after inline. So at this moment, we're only interested in the impure specifier, but we're going to cover the rest of them as long as they are going to appear in our code. We're going to talk about them. So impure specifier means that the function can have some side effects which can't be ignored. So it's actually affecting the state. So this is why it's called impure. You know what is pure function. And for example, impure means that it's going to affect the state. And for example, we should put impure specifier if the function can modify storage, for example, or send messages, or throw an exception, some data is invalid. And the function is intended to validate this data. So basically, if impure is not specified and the result of the function call is not used anywhere, then the FunC compiler will delete this function once it's going to optimize the code. So another important thing we need to do is to import stdlib fc file. So in order to manipulate data and write other logic in our contract, we need to do this thing to actually inherit the functions that are in this library. So currently this library is just a wrapper for the most common assembler or TVM commands, which are not built in. So each TVM command description used in the library can be found in documentation, so you can actually read much more about all these functions. And in order to import it, we need to create a folder in our contracts folder. We need to create another folder called imports. And inside of it, we will create a file stdlib fc. And you can actually find an attached link to this lesson, because you will need to get the stdlib code somewhere. So I'm going to copy it by myself now. and paste it here. As you can see, this is a standard library for FunC, all this documentation, and then you can see a number of constructions that are presented by this file. So, and we, of course, need to actually include it in our code. Great. So now we're good to go. And let's finally learn what we can do with these parameters that are passed into the receive internal. So whenever we want to handle an internal message, before we even start reading the meaningful in-message body part, we need to first understand what kind of internal message we received. There can be different cases. For example, we could receive this message because our contract previously has sent some message to someone, and the receiving party wasn't able to accept it, or for some reason it bounced it back. So we don't want to process this kind of messages. So we are going to talk about such scenarios later on in this course, but to detect if it's even bounced, we need to understand that every message we receive has flags in it. Flags are basically, because we have 4 flags, then we would need to process every bit to understand meaning of each flag. So those flags will actually tell us valuable information about the message. So for example, this message was bounced. As you remember, this is a cell, and a cell is a set of bits, and first bits inside of the message, inside of this in message, so it's the whole message cell. These are flags. So we would need to read them out from this cell, and to start reading, we would need to actually begin the parsing of the cell. So you see, we specify slice because here it would basically point into the very beginning of the cell. So basically, by running this begin parse function on the cell, we actually opening it for reading. And then we would read first 4 bits. So we use function load uint. And the result of these 4 bits, we would treat it as an integer, because we don't want to get into details of, we don't want to use all the flags, but we're going to read out an integer that is consisting of these bits. So let's break down what exactly happened in this code. And then we're reading out first 4 bits. So once we are going to call some more of the load something on the CS variable. So like CS here is just a cell slice. And we are going to actually, like, we read out flags. And now if we read something more from this CS slice, the pointer actually moves. So I could do, for example, that if I would want to read out, imagine this is not a message, but I want to read out something. So it would be like message something. I would continue reading. So it's basically like a continuous process where you can read out of the cell, like slice by slice, and you don't need to, you just opened it for reading once. You don't need to reopen it. So in case we're trying to read out something that doesn't exist there, we would actually get an exit code 9. So you can read more about codes also in documentation. You could just open the exit codes and you will learn more. But here, it's like if I wouldn't have this 4 bits written in this sequence of bits, I would actually get an error, exit code 9. So there is some more valuable information in the in-message cell, and namely, this is sender address. And sender address is standing there right after the flags. So as I mentioned before, I just keep reading from the same CS variable, because this pointer, it's getting, like it's following, if I read 4 bits, now it's on the 5th bit. So when we want to create a variable that stores address, we always use slice type. So we only store the pointer from where the memory should read the address once it's needed. So what are we going to do with variables that we already have? Let me first introduce you to another 2 capabilities of our smart contract. So our smart contract has a persistent storage. It's called C4 storage. You can read more about different types of storages also in documentation, but for now we'll need the C4 storage because everything is stored in memory. In turn, the code is stored in memory, and you will need to understand these different kinds of storages, but mostly you will use C4. And if you go more advanced functionality, then you might want to learn the other types of storages. So, second capability that I wanted to talk about is that our contract is able to have a getter method that would allow anybody from the outside or actually get some data from our contract. Other contracts cannot run this getter method. This is only for the outside world once we want to access some data that is stored inside of the contract. So using those two new capabilities, we can do a following thing. So we can store the sender address in our storage and create a getter method that would return like this sender address once it's called. So in other words, our getter would always return the address of a contract that sent a message to our contract the latest. So this is going to be the functionality of our simple contract. Like someone is sending the message and we store the most recent sender address, and then we make a getter method that is actually giving this information to anybody who wants it. So in order to store some data in our C4 storage, persistent storage, we're going to use FunC standard function called setData. So this function is accepting and storing a cell. So maybe we can even find it here, setData. You can see that it is actually gotten from stdlib FunC file. So let's update our code with setData. And this is just a setData that is using, like, it is saving an empty cell. So to pass cell into the setData, we would need to first construct it. So this is done easily with two functions, begin cell and end cell. So at the moment we are passing an empty cell. Technically it's fine, but we want to write the address of the message sender into the storage. So we should update our cell with this address. So we would actually do here, after we begin the cell, we would do store slice. And we would pass the sender address. Something we didn't discuss is this load message address. So as you can see that for different types, we would use different functions to load data that is stored there. So, and here you can see that we use store slice. So now we have a smart contract that is able to write a sender's address into the persistent storage. Every time our contract will receive an internal message, it will replace the cell that is stored in C4 with a new cell that we have a new sender address. So as simple as that. And it's bringing us to the fact that these persistent storage cells in general are immutable. So you cannot rewrite something. You would need to construct some new cell and actually replace the old one with a new one. So let's get to the getter methods. So I'm saving it here. And as you remember, we didn't want to just store the sender's address. We wanted anybody to actually be able to read them. So we've been talking about function specifiers recently. To make our data accessible outside the TVM, we would need to create a function with specifier method ID. And if a function has the specifier, then it can be called by Light Client or Tone Explorer as a get method. So it would look like this. So we are actually defining what it's going to return. It is slice. As you remember, the addresses or the slice type. So we call it get the latest sender. And we have to put the method ID specifier. And it's important to know that those are defined outside of the receive internal function. So as you can see, we define like what time is supposed to be returned by the function, what type is supposed to be returned. And now let's write the logic of actually reading data from the persistent storage and returning its value. So for this, we're using also a standard function called getData. So we used set data, and now we use get data. And again, when we run this get data, we receive this memory cell from C4 storage. And just like we did here with in message cell, we will need to open it for parsing. So DS is just a name of variable I call DS because it's like data storage. So, and here we go with reading the message, like the address of actual, just like here, sender address, we already reading it out. So here we use the same technique to return the slice with this message address. All right, so we get our code, and we can actually now try running yarn compile. Quite a simple contract. You can see that it compiled. And we learned quite a few things with you today. So we see that it's successfully compiled. And in this lesson, we actually learned quite a few syntax things of FunC, and I hope you enjoyed it. But this is just a basic, very basic code that shows us some of the first steps that could be done. And in next lesson, we are going to actually test it because, yes, it compiles, but we don't know if it functions the way we intend it to be. So see you in the next lesson and get ready for tests.